We left off on example 3 in lesson 1.4. We were working with fog. You got your fog this morning. And golf. Okay. F composed with G of X, G composed with F of X. So we did some practice of how to put these together. And then we were on this one and we were talking about the domain. Okay. So the domain, are there any restrictions of what X could be? And I remember now that I started talking about this, you guys had thrown out some, first it was all reals. Then you guys were refining it and you were throwing out infinities and ones at me and you didn't really get there, but you were on the right track. Okay. So using what we learned from domain back in lesson 1.2. If there's a denominator, it can't equal 0. Not the issue here. If there's something under the square root, it has to be positive, greater than or equal to 0. So I took x squared minus 1, greater than or equal to 0. That's what I set up right as we were getting ready to leave. And then if we're going to solve this, we're going to add 1 over, yes. And this is where it gets a little tricky. What do we normally do next? What will we do next to solve?
Take the square root.
You take the square root. The square root of x squared is going to become x. And what's the square root of 1?
1.
Plus or minus.
Square root of 1.
Plus or minus the square root of 1. Or plus or minus 1.
The square root of 1 is 1. In the equation setting, we have to say plus or minus 1. Yeah, do me a favor. Someone will always do it. Don't leave me a square root of 1 on your paper. Don't. Just don't. It happens. I always think, oh, you guys are smarter than that. And every year I get a handful that just didn't. Oh, wait, yeah, we do know that, don't we? So, you know. Okay, so here's the deal. I can't say x is greater than or equal to plus or minus 1. That's not an option. Okay, it doesn't make sense if you start thinking about it. So we have to break it into pieces. Remember when we have inequalities, we think about two statements, right? And there's obviously going to be two statements, one with a 1, one with a negative 1. Greater than or equal to is what kind of statement? An or statement, right? Because less than, I said and statement. Greater than, I said or statement. Those were my, So the first one I'm going to say x greater than or equal to 1. Or what's the other option here? X, and what do? We flip two signs. Greater than or equal to flips to, and positive 1 becomes negative 1. Okay, so we're actually going to have these two pieces. And if you think about a visual for a moment, greater than or equal to 1 means what? That's going to be everything to the right of 1, yes? Less than or equal to negative 1 means everything to the left of negative 1. Does that make sense? Think about the validity of our answer, okay? If I take 2, 3, 4, 5, negative 2, negative 3, negative 4, negative 5, can I put those in there? You square them, they are positive or become positive, subtract 1, you're still positive. Why can't I put in, say, 0? Because 0 squared minus 1 is negative, and we can't do a square root of a negative 1. Okay, we can't do it, well, and stay in the real numbers. Okay?
Does that mean there's a hole in the graph?
The graph is not going to exist in those spots. Throw it on your calculator. You have your calculator sitting there? I don't want us relying on the calculators. However, this is a really good one. You guys are probably going to have it before me. To throw on.
It looks like there's a hole.
I'm thinking.
Oh, what? It's not.
No,
Because it still gives points even when I can't see it.
What do you mean? Did you do the square root of x squared minus 1?
Square root of x squared minus, wait. Is minus 1 supposed to be under that?
Yes.
Yeah.
Minus 1 is under the
Okay, I
right.
did
Let
that.
me see what you're doing. Mine was like a V, just not finished.
Like
Come on,
that.
technology.
Let's see. That's what mine is.
My technology is
Get
not.
trace.
Yeah, but there's no Y. Look.
There's no Y no matter what direction you go.
Like,
Yeah. What you've got is you've got
Oh, I
two
see.
pieces of the graph going out. Notice that trace is 0, nothing. I'm going to have to go over to 1 before my Y value starts existing. So that's kind of your proof too. Okay. So there's nothing wrong with using the calculator to help us get along there. Okay. So how am I going to write this in interval notation? My first interval starts at negative infinity to what? Negative 1 with a bracket. Union. And my other interval starts at 1 with a bracket, comma, infinity with the parenthesis as always. Okay. So that is my domain there. So there's more than a hole, in my opinion. That's a gap. I just think of a hole as like one little like pencil mark type thing. So. Okay. Is the graph a good way to back yourself up?
Yeah.
Check your, I'm going to keep telling you, try the algebra, because there's things the algebra will tell you that it's hard to get off the graph. But if you know the algebra, you can be like, oh yeah, that makes sense. Okay. Like you can be like, oh yeah, that goes to 1 and negative 1. So, okay. So we did Pog and Goff yesterday. You're going to have to work to put those compositions together in homework. Now, we need to go the opposite direction. We composed functions. We put f and g together. Now we're going to decompose. So we're going to take f and g and we're going to separate. So basically, they're going to give us Pog, and we're going to decide, okay, this could be f, this could be g. Okay, so to decompose a function into two composed functions, you're going to find the inside function and replace it with x for the outside function. So, with the idea, in this example, h of x, so for each function, find functions f and g such that h of x is equal to f of g of x. And in that mind, what's my inside function going to be? My inside function is going to be represented by whatever g of x is. And that means f is going to be my outside function. Okay? Now, there's not necessarily just one right answer. On the flip side, there are incorrect answers as well. Okay? So, as you look at A, I need everyone to look at it and think about it without saying anything out loud yet, because this is one of those things is once someone says it, it's hard to, process it on your own. But I want you to look and see what will you think we could use as an inside function. Okay? And our inside function, we're going to call g of x. So what we could use as our inside function, that then when you take that inside function out, and you just put an x in that remaining hole, will be my outside function. And my outside function is f of x. Okay, so that's what we're needing. I just need you to write down g and f. In this scenario, since they defined it as f of g of x, g is on the inside, f is on the outside. I'm not sure I want to give too many hints yet. I don't know. Are we seeing any thoughts? You have a guess? Okay, what's your guess? What would you consider maybe for g of x?
X plus 1.
Okay, x plus 1. Why would you pick x plus 1? What makes you...
Because it's plugged in and it's repeated.
Okay, repeated. Could that be a good clue like, oh, hey, that should be my inside? Okay, so the fact that the x plus 1 is something that I'm seeing in a couple of places, that's a good indicator. Okay, and you can put the parentheses around x plus 1, but it's not necessary once you pull it out. Okay, so the fact that, like it's in the parentheses makes me think the x plus 1 is plugged in. The fact that it's repeated, that's another thought. Now, Here's the other half of the battle. If we use x plus 1 as our inside, okay, what becomes the outside function?
Would be the square root of -3 and the 4.
Okay, and what do we put in the place of x plus 1?
It would be x squared minus 3x plus 4.
Okay, so once you find the inside, then replace it with x for the outside function. So yeah, you see the squared, the -3, and the plus 4, but what am I putting in place of x plus 1? I'm replacing those with x. So I'm going to say x squared minus 3 times x plus 4. And the idea is if we did fog and we put g into f, we would get the original problem. Okay? Now, I'll be honest, on this one, I don't have another one that I look at and I say, oh, we could do it that way too. I don't have an obvious other answer. Okay? And I don't have anything written down, so I'm guessing I haven't really come across anything from people over the years. Are we okay with that? Okay, let's try B. Again, it's h of x. We're trying to find g of x, which is on the inside. And once you find g of x, you're going to find, gosh, can't write, f of x, which represents the outside. Now, I'll be honest, I do have 2 different options for this one written in my notes. I mean, I know which one I personally see and prefer, but, you know. Okay, thoughts on an option for the inside?
Can it just be x cubed plus 1?
That's what I like. If I take that entire x cubed plus 1, and here's the thing, last one was in the parentheses. This is what's under the square root, right? So if I take the x cubed plus 1, and I use that as my inside, what's my outside?
Would be a square root of x.
Because we're going to take the x cubed plus 1 out, and when you take that x cubed plus 1 out, you're going to replace it with x, so it's the square root of x. Now, if you're not 100% sure, because here's what's going to happen on your quiz. When I grade them, if your answer doesn't match the answer key, then what I do is I put it back together to see if it gets what it's supposed to get. And that's how I decide if you get credit or not. Okay? So, you can always test it that way. Did anyone else do anything different? Or does anyone just see a different option?
Could g of x just be x cubed, and then the f of x can be x squared of x plus 1?
So an alternate option, and I'll be honest, the first one we did is the one that to me is, I don't know, more obvious. I don't want to say more appropriate, but just makes more sense in my brain. Fair enough? But an option could be to say that g of x is just the x cubed. If g of x is just the x cubed, then look, you're taking out just the x cubed and replacing it with an x. So then you're looking at the square root of x plus 1. Okay? That's what I got for you. How are we feeling? It's just one of those things, it takes time to practice and see. I don't have a better, it takes practice. Okay. Let's go to the back page. I believe this problem maybe matches up with 31 in homework. I don't remember. So, in the medical procedure angioplasty, a catheter is inserted into a heart vein in order to inflate a small spherical balloon. Suppose the balloon inflated at a constant rate of 44 cubic millimeters per second. We're going to start by finding the volume after t seconds? Because you're not a medical person?
Not insert things in the name.
Okay, well. Still gotta do a word problem about it. Sorry about your luck. Okay, so the first thing is to find the volume after t seconds. What do we know about the volume?
It's a constant rate.
Okay, it's a constant rate. What is the volume?
44, well, I guess that's the rate. Was that what you're looking for?
Yeah.
44 millimeters cubed second.
Right? So where's your blinking sign that says, hey, volume right here? What's telling me that there's volume here?
Cube.
Cubed, yes? What does a cube label tell us? Volume, right? A squared label tells us area. A cube label tells us volume. Also the fact that the balloon is inflating. What happens as a balloon inflates? It's getting bigger. Volume is the space inside something, right? There's your basic elementary reminder. Volume is the stuff inside. So it's going to be the air inside of that balloon. So if the balloon is inflated at a constant rate of 44 cubic millimeters per second, tell me. We're going to go very basic here. What do you know after 1 second?
44 millimeters cubed.
The volume is 44 cubic millimeters, yes?
Mm-hmm.
Logical? I'm using what I'm given, right? Okay, let's me go one more step. What do you know after 2 seconds? Because it's 44 per second. 44 times 2 is 88 cubic millimeters. Are we there?
Yep.
Now, our question on A is to find the volume after t seconds. What am I going to write for volume after t seconds? 44 times t. Because for volume after 1 second, it was 44 times 1. Volume after 2 seconds, 44 times 2. Volume after 3 would have been 44 times 3. I wasn't going to keep going and boring us on. But volume after t seconds then is going to be 44 times t, or in other words, V equals 44t. Did I get you there?
Yeah.
Maybe you didn't get there at first, but I always feel like if I break that down, it makes more sense. Okay, let's look at B. When the volume is V, what is the radius? When the volume is V, what is the radius? So I need an equation that connects volume and radius. Now, volume and radius of what shape?
Sphere.
This is a spherical balloon. They specifically told you. You're not having to guess what shape this balloon is. Okay? Spherical balloon. Anyone know it? Formula for volume, and we're going to work with it, but formula for volume of a sphere?
V equals pi r squared.
No?
It's just,
We're not using that information. I just want, aside from this situation, what's volume of a sphere?
Oh no.
No? Here's a hint. Starts V equals.
Oh no.
does it have pi in it?
Of course.
1
Pi
pi.
r squared. No, we just tried that.
V
Oh,
equals.
pi times r.
Wait, does it do with 3/4 or something? Is that the one?
Ooh. Not 3/4 though.
V equals 1/2.
1/2.
4/3? Oh shoot!
Pi r.
So close.
V equals 4/3 pi r squared.
It's volume, so
Cubed.
cube.
Oh man.
That's one of those formulas you've seen, you've used, you learned, you just don't remember. It's been a hot minute, right? Okay, so the formula for volume of a sphere, I didn't make that up, that's just fact, is volume equals 4/3 pi r cubed. Now, they say when the volume is V, what is the radius? So we need to take this equation and solve it for R. How would you like to solve this for R?
What, you put in 44 for you?
No, I'm solving for R. I'm just working with this equation here, right now. How do we get R by itself?
You have to divide the 4/3 and pi over.
Can you go ahead and multiply the 4/3 with that, or do you move it over?
Either way.
Did you do?
If you're talking about what, making it what, 4 pi over 3, is that what you're thinking? Before you move it over? Or,
Or like,
I mean, we can move them individually too. How would we move the 4/3 over?
Keep change foot,
Meaning I'm going to end up doing what?
dividing it. Multiplication.
Multiplying by
Multiplying.
3 over 4. Because if I want this 4/3 to cancel out, I'm going to multiply by 3 over 4, yes?
Yeah.
If I multiply one side by 3 over 4,
The other.
we're going to multiply the other side by 3 over 4. You still with me? Now, 3 over 4 times V. How could I write that as one fraction? Three over 4 times V over 1. I'm going to write it as 3V over 4 just because of other stuff getting ready to happen. 3/4, 4/3 cancel. I'm left with pi r cubed. Now, we could have done it all in one fell swoop, but I didn't. We still have to move the pi, yes? What are your options for moving pi?
Divide by pi.
Divide by pi. Now, I'm going to hesitate divide by pi because I already have a fraction over here. Dividing by pi is the same as multiplying by what? If I was dividing by pi, you would tell me to do something. If I was saying doing,
Keep change flip.
I was going to make up 5/7 divided by pi. You would tell me to keep, change, flip, which makes it 1 over pi, yes? So I'm suggesting that we're going to multiply by 1 over pi. Does that make sense? Now, what I do to one side,
You did the other.
we do to the other side. Okay? 1 over pi times 3v over 4. 3v over 4 pi, if you will. 1 over pi times pi is going to cancel, and I'm left with r cubed. What's my final step in solving for r?
A cube root.
Cube root. What you do to one side, you do to the other side, and we end up with the cube root of r cubed is r. The cube root of 3v over 4 pi is,
Cube root of 3b over pi.
you got it. Okay. Now, we've got to quickly do part C. Part C has 2 questions in it. First of all, write an equation that gives the radius r as a function of time t. So we want an equation that says r equals, in terms of time t, means it has a t in the equation. Now, what do we have already that's r equals?
The r equals the cube root.
We already have r equals the cube root of 3v over 4 pi, correct?
Yeah.
Now, that's writing the equation that gives the radius, but that's the radius as a function of v. I didn't ask for a function of v, I want a function of t. What connection do you know between v and t?
Did we replace the b in that the r equation for 44t?
We know v is 44t. Okay, so we already used that equation. we're going to replace this V right here with 44t. So R is the cube root of 3 times what's V? 44t over 4 pi. Now, we can go big or we can clean up now. I'm not going to multiply yet. What can I clean up in that fraction? 4 and 44. 4 divided by 4 is 1. 44 divided by 4 is 11. So now put it together. R is the cube root of, and what is 3 times 11t? 33t over pi. Okay? Now, that is R as a function of t. Now, the question says, what is the radius after 5 seconds? What do you think we're going to do?
Swap 5.
You're plugging in 5 into t, yes? This becomes a calculator question because I don't know the cube root of any of that stuff. It rounds to be 3.74 millimeters. Okay? Okay, guys. Homework. You've got to get it done. Okay? 2 through 8 evens, 12 through 30 evens, and 31. You got to get it done. Put serious work into it. There are some doozies in it. Okay, so be ready to come back and talk questions, but know where your questions are. Don't just be like, oh, this section looks hard, I'm going to skip it. No, know what you're doing before tomorrow, okay?
Right,